Guys, all of us know that memory management is an important aspect of programming. All the time we hear this in college lectures that we have to analyze the space complexity of a program, right? I mean, look at this simple code. If I declare a variable as an integer, you could see that it is taking up to 4 bytes of memory, right? In case of C or C++ language, you have to deal with the memory manually. But when it comes to the Java, the JVM itself does the memory management. So my goal for this video is to help you understand how it is done. Hello and welcome everyone to the video on garbage collection in Java by Intellipaat. In this video, we will understand the nonsense of the memory management in the context of Java programming language. But before we begin, subscribe to our Intellipaat YouTube channel and hit the bell icon to receive more updates like this. So we will start by understanding what is garbage collection in Java. We can simply define garbage collection as the process of automatically reclaiming unused memory by destroying the used objects. So what does this mean? Let's try to understand this with the real-life examples. Suppose you use whiteboard for writing to-do tasks and you end up writing the 5 tasks and there is no more space to write. Once you complete the task, you need to add another task, but for that there is no more space on the board. So what will you do? You will simply remove the task from the board which is completed because there is no use of that. So in this way you can recreate a space and write your task. In similar fashion, in programming, we need to free up the space from the memory. If you don't do so, then at certain point you won't get sufficient memory for creating new objects, and due to this the entire program will terminate abnormally, causing out of memory errors. In programming language like C, C++, the programmer needs to free up the memory by deleting the unused or unwanted objects themselves. But in case of Java, the programmers don't need to think of it. The unused or unwanted objects automatically get deleted, and this is called the garbage collection in Java. I hope now you guys are clear with this. Now moving forward, we will look into how garbage collections works. See, there are various methods of garbage collection such as making reference null, assigning a reference to another, and using the anonymous object. So here we can see that we have declared an object that is car1 and we are assigning car1 to the null. So this is what the making the reference null. Apart from that, assigning reference to other. So here we have declared two objects, car1 and car2, and we are assigning the value of car1 is equal to car2. In similar way, the third one is the using the anonymous object. And let me clear you guys, these methods are all automated. So mainly there are 3 steps involved in the garbage collection. The very first one is mark. So the garbage collector scans the heap memory segment and mark all the live objects. And the second one is sweep. Then sweeps comes into play. So in this step, the garbage collector recycles all the unreferenced objects from the heap. And the third step is compact. See, what basically happens, sweeps steps leaves many empty regions in the heap memory, which causes memory fragmentation. Hence, compact helps in arranging the objects into the contiguous blocks. So simply we divide it into 2 parts, young generation and old generation. So young generation is the memory space where the new objects are allocated. The old generation is the memory space where long-lived objects are eventually moved. After that, we can divide young generation into 2 parts, that is hidden space and the survivor space. Hidden space is the main area in the young generation where the objects are created. Survivor space is the spaces within the young generation where the objects that survive one garbage cycle are moved. After that, the survivor space is divided into 2 parts, that is from space and to space. Now moving forward, we will try to understand this with the help of diagram. So this is the memory and this is the heap space. Apart from this is the young generation space. Inside the young generation space, this is hidden space and this is from space and this is to space. So, and this is the old generation space and this is permanent generation space. Initially, when we declare the object, it gets stored in the hidden space. So, in this space, when the objects are alive, that is sent to the from space, which is also known as minor garbage collection. So this process continues to happen. When we declare the object, it gets stored in the hidden space and the object which is not dead is sent to the from space. So this process continues to happen, and once even in the from space some objects are dead and some objects are alive. So the alive object is finally sent to the to space, and the object which is in the to space finally moved to the major garbage collection, that is old generation. So whatever the live objects are there in the two space are eventually moved to the old generation. So once the object are moved to the old generation, it is considered as a long-lived object. I hope now you guys are clear with this. Now moving forward, we will look into the types of garbage collection. The very first type of garbage collection is serial garbage collection or serial GC. Serial GC is well matched for the single threaded environment. What does this mean? This means it uses only one thread of the garbage collection and it works by holding all the threads of an application. It means that the threads of the application freezes by the serial garbage collector during the process of garbage collection, and this process is known as stop the world. We should always avoid the use of serial GC in the server environment. Yes, of course, we can use it for the simple program, not for the complex one. Now moving forward, we have parallel garbage collector. So guys, parallel garbage collector is the default GC used by the JVM. The working of a parallel garbage collector is same as a serial garbage collector, but the only difference is in serial we use only single thread, but in parallel we use multiple threads for the garbage collection. So the parallel GC can use multiple CPUs to speed up the application throughput. So this is also known as throughput collector. It is used if you want to execute a long process like a batch processing and where the long pause are acceptable. Now moving forward, on number 3 we have CMS garbage collector. CMS uses multiple threads that scan the heap, and during the scanning it marks the instances for eviction. After scanning, it sweeps the marked instances. So it does not freeze the application's thread during the garbage collection like we have saw in the case of serial and parallel GC. So the GC threads concurrently execute with the application's thread. For this reason, it uses more CPU in comparison to other GC. So it is also known as concurrent low pause collector. Now moving forward, here we have another type of garbage collector, that is G1 garbage collector. The G1 garbage collector is used if we have large memory, that is heap space. The G1 garbage collector is used if you have large memory, that is heap space, and it should be more than 4 GB. So it divides the heap into equal sized chunks and prioritize them, and then perform the parallel garbage collection on that chunks based on the priority. So the hidden, survivor and the old areas use this equal sized region for the memory allocation of the objects. After this, G1 garbage collector shows a concurrent global marking phase to determine the live and the dead objects throughout the heap. After the completion of mark phase, G1 collects the information of regions that contains the most garbage object. Here we can see that this region has the most garbage object. So after this process, these regions are swept first. So that's where the types of garbage collector. Now moving forward, we will look into the advantages of garbage collector. The very first advantage is automatic memory management. So with the garbage collection, you do not have to manually manage memory allocation or deallocation. This means that the programmer can focus more on writing the code and less on managing memory, which can help to reduce error and improve productivity. And the second advantage is prevention of memory leaks. What does this mean? This means that the garbage collection helps in preventing the memory leaks, which can occur when a program does not release memory which is no longer needed. This can cause the program to consume more memory than the necessary, leading to the slow performance and eventually crashing. So that's all we got in this particular video. So thank you for being all the way to the end, and to see more updates like this, follow the Intellipaat YouTube channel.
Just a quick info guys, Intellipaat offers Java certification training course. Through this certification training course designed by top industry expert will help you master the Java programming language. We provide the best online training classes to help you learn OOPS concept, core and advanced Java, JDBC, objects and classes. As the part of training, you will get to work on real-world industry projects. With this course, we have already helped thousands of professionals in successful career transition in IT industry. You can check the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take a first step towards the career growth.